Midori-chan. So Midori-chan is basically a Japanese word, whereas Midori means green in Japanese, and chan is something you address kids or even younger girls. For example, you say san after a Japanese name, so chan is added to kids' names. So today we see there are major problems around the world in terms of water shortages. We see that there's a lot of major cities in the world having water shortage, there's global warming happening, and they also see the temperature rising. So we feel that the Midori-chan system and the concept that it brings to you can definitely address some of these concerns. So what is the Midori-chan system? So the Midori-chan system is basically a revolutionary Japanese greening system developed by Kawada Industries. It uses just natural rainwater and recycled waste material to promote maximum vegetation growth while minimizing maintenance and water usage. So we'll just look at some of the applications of the Midori-chan system. So the Midori-chan system is designed, basically you can use it anywhere. So just to give you some examples like rooftops, roadside projects, pavements, medians and landscaping works. And our system, like I said, since it uses only natural rainwater, it does not need to be equipped with an irrigation system. So in most of our projects, we see that we do not install an irrigation system. And our system is also truly green by, as in all materials are made from recyclable materials, or the materials used are all recycled materials. So what are the benefits of the Midori-chan system? So firstly, we see that it dramatically uses less water than conventional greening systems. So there you see a lot of savings in terms of water cost. Then we see that the temperature around it also reduces. So for example, if you set up a Midori-chan system on a rooftop, we notice that the room below it, we see a drop in temperature because it cools the rooftop because you have a green space on your roof. And then decreases the thermal load of the local environment by transferring heat to the vegetation. Then we also notice that the carbon dioxide from the atmosphere is removed, and we also are able to reduce the carbon footprint to a certain extent. And we also offer flexibility in terms of loading constraints by tailoring soil depths. This way, we see that the load on a structural building is actually reduced because our system is able to grow potential plant species by using minimal soil depths. And as you can see, there's overall cost savings in terms of maintenance and water usage. So how does the Midori-chan system look? So this is a typical diagram of how a Midori-chan system will look. So you see that we can use it not only on plain surfaces, but also on contoured surfaces. So we see that there are different layers for the Midori-chan system, starting with the water storage units right at the bottom. So the Midori-chan system actually harnesses the power of nature, by making the most of rainfall, creating a truly green and sustainable space for your project of any size. So just to explain how the system works, so once it rains, the rainwater is cleaned and filtered through Kawada's special capillary action soil mix and a layer of regenerated charcoal, and it collects in the water storage units. Now, the design of the water storage units is very unique. The units are locked and interlinked, much like ice cube trays. So this also helps to enable the excess water to drain away naturally. And then above that, we have a raisin net, which actually enables a hassle-free installation of the regenerated charcoal bags. And above that, we have a root barrier. So what this does is the vegetation which is planted in the soil, the roots do not have access to the filtered rainwater directly. This actually helps to reduce the consumption of water by the plants. So we supply only adequate amount of water to the plants. And you also notice there's an air gap which is created. This is created because of the design of the trays. So during hot weather, once the soil dries up, the charcoal will absorb water vapor present in the air gap and supply it to the soil. So this way, we are able to control the amount of water that the plant takes. We are able to supply only the required amount of water to the plants. The system also maintains structural integrity, as in even if a passenger vehicle drives over the system, you see that there's no damage done to the system. Whereas if you consider a conventional system, even by foot traffic, you see that the system can be damaged. So our system maintains its structural integrity very well. So these are just some of the parts, and the parts can be of the water storage units are of two different sizes based on the customer requirement. So each of it, the first one on the left side has a 34 liter per square meter, and the one on the right has 16 liter per square meter. So, like I said, it depends on the customer. And these are some of the other parts. So moving ahead, so this is the vegetation characteristics. So just to give you an example, if you look at the soil thickness, it's very low compared to conventional system. For example, for grass, we just use 50 of soil. And likewise, moving ahead, depending on the size of the plant, the soil thickness increases, but very, very less compared to a conventional system. And on the last line, you can also see the dry weight. So again, it's very, very low compared to a conventional system. So we did a case study in Hong Kong. So the MTR Corporation is one of our major clients. MTR is basically the Mass Transit Railway Corporation in Hong Kong. It's a mass public transportation system. So we did a comparison with the conventional system available in Hong Kong. And we noticed that the conventional system uses about 190 liters of water per square meter per month, whereas our system used just 0.35 liters per square meter per month, which was an astonishing number. But then we continued to do further trials. We changed the formulas, and then we came out with a even lower number. We just used 0.17 liters per square meter per month. That was incredible. If you look at it, we used just 2 liters per square meter for a whole year. So that was a astonishing number. So moving ahead, so this is the global presence of the Midori-chan system. We have projects and trials happening in different countries. And in India, we set up 3 trial projects last year, and hopefully we should be getting in the results by the end of this year, and officially launching it probably next year sometime. So this is another comparison, just to give you a comparison on over a 10-year period. So we took a 100-meter square area for over a 10-year period. We noticed that the conventional system will use about 2.5 million liters of water, which is actually the size of an Olympic swimming pool. And the Midori-chan system will use just 2,000 liters of water over a 10-year period for an area of 100 meters square, which is very, very less. And the costs are very evident, the water saving costs. And it also helps, since most of these cities are struggling with water shortages. So we definitely feel that our system can address those concerns. So this is the installation sequence. The installation sequence is pretty straightforward. As you can see, it just has very, very few steps because the parts are just about 5 parts. We start with the water storage unit, and then the raisin net. We have the root barrier, the charcoal bags, and then the soil and the plants. So this was set up on top of a building in Hong Kong. So even younger kids are able to do an installation. For example, we had a school in Hong Kong, and the kids were very enthusiastic there, and they also wanted to take part, in the installation process, and they were able to successfully do it, and they really enjoyed it. So it's a very straightforward process. So now I'll just show you some project samples which we have done. So this one is in a station. So as you can see, the system is set up in between the tracks. It just improves the beauty and the aesthetics of the area. And this one is a park in Aoki. So this can be also placed beside bridges. It just improves the overall look of the area. And this is another building. It's called the Wing Wing. And this is on top of a hospital. So as you can see, this can also be installed in steep angles. So there's no issue with the Midori-chan system being installed in angular areas. This is another campus in Sagamihara. So this is on top of a school. So as you can see, the system is installed on the rooftop, and it's actually a small football ground. So you see the kids are running on top of it and playing. So you see that the system is not damaged, and it's very safe. So it's a great thing. As you can set, if you have space problems, you see that the playing area can be set up on top. And another advantage is the structural load of the system is also very low. So there's no damages done to the structural integrity of the building also. So this is on planter boxes. So these are probably suitable for even houses, balconies. You can set up planter boxes and you can have our system inside it. And this one is actually a museum. So this is one of our trademark projects. It is actually around 30,000 square feet of rooftop space. So you see that this is actually a complete playing area for kids. It's actually a mini park, which is actually set up on top of this museum in Toyama. And this one is also a trademark project and is also the largest of the projects so far. So this one is done for the MTR Corporation in Hong Kong. And as you see, it is on top of the railway system, so it cools the area inside the stations. It's also very aesthetically pleasing and very clean. So yeah, so as you can see, so that was the Midori-chan system, and our whole mission is to encourage greener and cleaner communities and help create a sustainable future for all. I hope you enjoyed this presentation of the Midori-chan, and we would love to get your feedback either on the comments or on, you can always contact us through our web link or other contacts. So yeah, thank you very much for joining in.